So this is the infrared phototransistor. Infrared phototransistors are sensitive to infrared photoradiation. So if I shine infrared radiation onto this phototransistor, there is a flow of current between the collector and an emitter of this transistor. Speaking of transistors, usually a regular transistor like this one here, BC547, has 3 leads, a collector, an emitter and a base. But a phototransistor has only 2 leads. So in this video, with a series of circuits, I am going to demonstrate how a phototransistor has only 2 leads. So let's begin with photodiodes. What I have here are 2 infrared photodiodes. They emit infrared radiation when you apply a voltage across its terminals. I am going to hook up a 3.7 volts across a current limiting resistor to this photodiode, and you can see that it's emitting infrared radiation. The reverse is also true with infrared photodiodes, which means that if you shine infrared radiation onto this photodiode, there is a small voltage and current generated at its terminal. I'm going to place one of the photodiodes onto a breadboard and then hook it up to a multimeter. So you can see here that when I'm shining infrared photoradiation onto this photodiode, there is a small voltage generated at its terminals. You can also see that there is a very minimal current flowing through the photodiode when I am shining infrared radiation to it. But this current and voltage is so low that you cannot drive another circuit with this. So if I want to drive another LED that is triggered by this diode, I need to add a transistor in between to amplify the current that is produced by this photodiode. So this is where the term transistor comes in. I'm going to use BC547 as an amplifier here. So let's build the circuit. The collector of the BC547 is connected to positive 3.7 volts. The cathode of the photodiode is connected to the positive 3.7 volt and the anode to the base of BC547. A resistor is added to the emitter of the transistor, and then a LED is added in series to this resistor. The cathode of this LED is grounded. The circuit is now complete, and let's check it out. You can see that now if I shine infrared radiation to this photodiode, the transistor amplifies the small voltage and current generated by the photodiode, and the amplified voltage and current is powerful enough to drive this small LED here. So the transistor performs a really important job of amplifying the small voltage and current generated by the photodiode. Now, if we can package the photodiode onto this transistor, you don't need a separate photodiode and a separate transistor. You would need just one component. And this is how a phototransistor is built. The phototransistor has a photosensitive diode hooked up onto its base and packaged inside a single package. So the phototransistor needs only a collector and an emitter. It does not need 3 separate leads as in the case of a regular transistor. So in this circuit, let me remove the photodiode, the BC547, and then add a phototransistor instead of the 2 separate photodiode and the transistor. With the phototransistor added to the circuit, you can see that if I shine infrared radiation directly onto this phototransistor, the phototransistor is able to produce adequate current to drive this small LED here. But unfortunately, the brightness of LED is kind of low compared to when using a dedicated separate transistor. But this does the purpose. You can see that with phototransistor, you don't need 2 separate components, that is a photodiode and a transistor separately. So this is the story of the phototransistor. So thank you for watching this video. If you like this video, please do consider subscribing and liking this video. Thank you.